Assalamu alaikum my dear students, hope you are well by the grace of Almighty Allah. Welcome to NIB Some School. This is Emdadul, Assistant Teacher of Mathematics, National Indian English Version School. Dear students, today I am going to conduct a higher mathematics class of class 9. Our today's topic is exercise 11.4, question 24. This is a creative question. This question I will solve in our today's class. Dear students, homework is given for our today's class. In our today's class, I have selected example 25 for your homework from this exercise 11.4. So example 25 is your homework and this homework number is 13. Okay dear students, let us see what is question 24. Let us see the question at first. Four corner points of a quadrilateral are P 5 2, Q minus 3 2, R 4 minus 1 and S minus 2 minus 1. First question, determine the equation of straight line PS. It means that here P is a point and S is a point. We need to determine the equation of straight line of this passing through these 2 points. Question 2, determine the length of the diagonal of the square that has the same area as that of quadrilateral PQSR. Dear students, here if you see in your book, this is written as PQRS, but if you put these 4 points in the, if you plot this point on the graph, you will get the points PQSR sequentially to form a quadrilateral. So there is a little mistake in the question, you can correct that one. The quadrilateral should be PQSR, but in your book this is written PQRS. Here also in question 3 also same mistake given here, so you can correct question 3 also. This will be quadrilateral PQSR, not PQRS. When I will plot the points on the graph, you will see that the quadrilateral is PQSR. Dear students, now see here question 3, determine the area of that portion of the quadrilateral PQSR which resides in the second quadrant. Dear students, when I will solve this question, I will explain what is said in the question. So I will solve first question at first. You can see the solution of first question here. Here solution I can write solution, that is part 1. Where is part 1 here? Part 1 is determine the equation of straight line PS. To determine the equation of straight line, 2 point P and S we can take from the stem. So we can write here given P 5 2 and S minus 2 minus 1, minus 2 minus 1, B 2 points, B 2 points. So joining these 2 points you will get the straight line PS. So we can write here the equation of straight line, equation of straight line PS. We can write here, dear students, 2 points P and S are given. We need to determine the equation of straight line. How can we determine the equation? For this we need a formula. If a point is x1 y1 and another point is x2 y2, then the equation of straight line passing through these 2 points is, you know, that is y minus y1 by x minus x1 is equal to y1 minus y2 by x1 minus x2. Using this formula we can determine the equation of straight line PS. We can determine the equation of straight line PS. As point P and S are given, it means 2 points are given. So we can determine the equation using this formula here. This is x1 y1 x2, y2. So we can write the formula here, that is y minus y1 means 2 here, by x minus x1 means 5 here. Then that is equal to y1 minus y1 means 2, y2 means minus 1. And here x2 minus x1 minus x2. x1 is 5 minus x2 is minus 2. So we can write here y minus y1 by x minus x1 is equal to y1 minus y2 by x1 minus x2. So applying the formula we will get the equation of straight line. So we can write here, that implies y minus 2 by x minus 5 is equal to, if we calculate, this will be 2 plus 1, this will be 5 plus 2. So we can write y minus 2 by x minus 5, that is equal to 3 by 7. Now we can do the cross multiplication, that is 3x minus 15 is equal to 7y minus 14. Now we can determine the equation of straight line. Take 7y and 14 in the left side, you will get here 3x minus 15 minus 7y plus 14 equal to 0. Then we will get here 3x minus 7y, here will be minus 1, that is equal to 0. So this is the required equation of straight line of the passing through the point P and S. It means this is the required equation of straight line PS, which is the required equation. We can write which is the required equation of straight line. Equation of straight line. Okay, dear students, so I hope you have understood how to solve the first question. Now I will solve the second question. What is the second question? Now see. Here second question is, determine the length of the diagonal of the square that has the same area as that of quadrilateral PQSR. It means that here 4 points, it means corner points are given. If you notice here, if I show here, this is, suppose this is x-axis, this is y-axis. Now put the point here, 1, 2, 3, 4, 5. Now 1, 2, 3, 4. If we put the point here, first one is 5, 2. Here is 5, 1, 2. So we'll go to here. We'll go to here. Next one is, this is point P, 5, 2. Now put the point Q. Point Q is minus 3, 2. Here we can write the given points at first. Solve 2, given P, 5, 2, Q, minus 3, 2, R, 4 minus 1, and S, minus 2 minus 1. B, 4 corner points of a quadrilateral. Okay, so we can put the point here. Point Q is minus 3, 2. So we have to come here 1, 2, 3. Minus 3, 2. Suppose this is here. Minus 3, 2. Suppose. Now this is point Q. It means that minus 3, 2. Now we can put point R. Where is point R? Point R is 4 minus 1. So go to 4. Here is minus 1. Minus 1, minus 2. Here is minus 1. Suppose. Here is minus 1. So If you notice here, this is -1, and then next point, this is R 4 -1. Now next point is -2 -1, so this will be -2 -1 here, -2 -1. Now if we join this will be a quadrilateral. This is S -2 -1. Okay dear students, so I hope you have understood how to plot the points. If you plot the points, you will get the quadrilateral PQSR. Now you can determine the area of this quadrilateral easily. You have to take the points anti-clockwise to determine the area. So we can write here the area of the quadrilateral. Area of the quadrilateral PQSR, that is equal to, we can take the formula half. Then first point is P52, second point is Q, that is -32, third point is S, that is -2 -1, and last point is 4 -1, and then we have to repeat the first point 52. So determine the area. You will get here half 5 to 10. At first we have to multiply this diagonal 5 to 10 plus, here is product of minus and minus is plus, that is 3, 3 ones are 3, now 2 ones are 2, minus and minus is plus, so here will be plus. Now 4 twos are 8 plus. Now no need to give plus here, now we have to give minus. This diagonal we have to give minus. This will be -3 and +2, that is -6, and here is minus, it means this will be +6. Then here should be minus in the formula, that is -4, so this will be +4. Product of 4 and -1 is -4, so this should be +4 as minus in the formula here. Then last one, this is also -5, it means this is +5. So now if you calculate, what will happen here? 10, 3, 13, 15, 23, 29, 33, 37 and 5, that is 42. Half into 42, it means that we will get here 21. 21 square unit is the area of the quadrilateral PQSR. Dear students, now read the question carefully again. Question 2. Determine the length of the diagonal of the square that has the same area as that of quadrilateral PQSR. It means that you have to consider a square whose area is equal to the area of the quadrilateral PQSR. Suppose this is the square. Its area will be 21 square unit. Now we need to determine the length of the diagonal. Length of a diagonal. If we want to determine the length of a diagonal, we have to determine the length of one side. If one side is A, then another side is A, it means all the sides are A. Then the formula for determining the diagonal is A in √2 into A. This is a diagonal. So if we consider a side is A, what will be the area of the square? That is product of A and A means A square. So we can find out or determine a condition, that is A square is equal to 21. From this condition we will get the value of A, it means length of one side of the square. If we get the length of one side of the square, then we have to multiply that by √2 to get the length of diagonal. So we can write here, let the length of one side of the square is a unit. So the area of the square is a square unit, and the length of the diagonal of the square is, that is root 2 square root 2 into a. This is unit. So at first we have to determine a condition, that is a square is equal to 21. We can write as per condition, we can write here a square equal to 21. Therefore, if we do the square root of 21, we'll get here 4.58. We'll get here 4.58. That is the square root of 21. That is 4.58. So dear students, we can say therefore the length of the diagonal of the square, therefore the length of the diagonal of the square, that is equal to square root 2 into a, that is equal to square root 2 into a means 4.58. So if we calculate here, this will be unit. So if we calculate here, we'll get 6. If we calculate, we'll get here 6.48, 6.477. It means 6.48 unit. So this is the length of a diagonal of the square whose area is equal to the area of the quadrilateral PQSR. Okay dear students, so I have done question 2. I hope you have understood the solution of question 2. Now I will solve question 3. For question 3 also we have to write the given points and we have to draw the figure. So I will not erase the given information and the figure. Dear students, so see question 3. What is question 3 here? Question 3 I am going to solve now. Here question 3. Determine the area of that portion of the quadrilateral PQSR which resides in the second quadrant. Dear students, so look at the figure here. This portion of the quadrilateral is in the second quadrant. This is the first quadrant, this is second quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. So in the second quadrant, if you notice, you will see this information here. So we can write here, suppose this is origin O00, this is origin, and this QS intersect x-axis at M and PQ intersect y-axis at N. So if you can determine the coordinates of point M and N using the coordinate Q, M, O, N, you can determine the area of the quadrilateral which is contained in the second quadrant. Portion of the that is the portion of the quadrilateral PQSR. Okay dear students, so to determine that, at first we need to determine the equation of the straight line QS to get the point M, and then we need to determine the equation of the straight line PQ to determine the point M. Okay, if point N, then we will get these 2 points, and we know this is origin is 0 0. So using this point we can determine the area. So we can write here given P 5 2, Q minus 3 2, R 4 minus 1, and S minus 2 minus 1 be 4 corner points of a quadrilateral. Now we can determine the equation of straight line QS. The equation of straight line QS we can determine using the formula that I have used in first part, that is y minus y1 by x minus x1 is equal to y1 minus y2 by x1 minus x2. Here y minus y1, here y1 means 2 and x1 means minus 3, so that is 2 by x1 means minus 3 means x minus 3 means x plus 3, that is equal to, here we have to write y1 minus y2, y1 is 2, y2 is minus 1, 2 minus minus 1 means plus 1, and that is x1 means minus 3 minus minus 2 means plus 2. So we will get here y minus 2 by x plus 3, that is equal to 3 by minus 1, that implies y minus 2 by x plus 3, that is equal to minus 3 we can write. So we can calculate here, we can write here, that is y minus 2, that is equal to minus 3x minus 9, minus 3x minus 9. So we can write here y equal to minus 3x minus 9 plus 2, therefore y equal to minus 3x minus 7. So dear students, we have determined the equation of straight line QS, that is y equal to minus 3x minus 7. Now we can determine the coordinates of M as this QS intersect x-axis at M as, or we can write, let the straight line QS intersect x-axis at M. Then what will you get? As QS intersects x-axis at M, so at point M the coordinate of y is 0. So we can put here 0, 0 equal to minus 3x minus 7. That implies 3x equal to minus 7. What does it mean? It means that x equal to minus 7 by 3. So the coordinates of the point M is minus 7 by 3 minus 7 by 3 0. This is the coordinate of the point M. Now we need to determine coordinate of point N. We can determine here the coordinate of point N. How can we determine? For this, at first we need to determine the equation of straight line passing through PQ. It means the equation of straight line. We can write here again the equation of straight line. PQ. Here the equation of straight line PQ, what will be the equation? We can use the same formula, that is y minus y1 by x minus x1, that is equal to y1 minus y2 by x1 minus x2. So we'll get here y minus 2 by x minus 5, that is equal to 0 by 8. It means that y minus 2 equal to 0, that implies y equal to 2. Now if the straight line y equal to 2 intersect y axis at n, then the coordinates of n will be, this is a straight line parallel to x axis, so this straight line will intersect x axis at, we can write here the straight line. So the straight line PQ intersect y axis at, as this is y equal to 2, it means on the y axis x is 0, so we can write here n, that is 0 2, we can determine the area of the quadrilateral. Now we can determine the area of the quadrilateral QMON. Now as we know, all the points here, O is the origin, we can write here as O, 0 0 is the origin, of the both axes so we can determine the area in the second quadrant portion of the quadrilateral PQSR. So we can determine the area here. Dear students, now see here, I'll determine the area here. So the area of the portion QMON of the quadrilateral PQSR in the second quadrant. We can determine that is equal to half. We have to take the points here. So we have to take the point, as we have to take the point anti-clockwise to determine the area. At first we can take QMON. Here coordinate Q minus 3 2. Coordinates of Q minus 3 2. Then M is, we have determined here, minus 7 by 3 0. minus 7 by 3, 0. And then O is the origin, the coordinates is 0, 0. And last point N, coordinate is 0, 2. 0, 2. And at first we have written the first point Q, that is minus 3, 2. We have to write again. Minus 3, 2. So here will be the area. We can multiply this diagonal. This will be 0 plus this will be also 0. Now this will be 0 plus this will be also 0. Now we can write here, this is, here should be minus, here should be minus in the formula. Now we can multiply this, we will get here 7 2s are 14. As here is minus, this will be plus, 14 by 3. Then this diagonal is 0, so we can write here minus 0. We can write here this diagonal minus 0 and this diagonal. Here minus for formula, and this will be minus 6 for this one, this will be plus 6. Now we can write here half. We can do the sum here. If we do the sum, what will we get here? We will get here 3, 14 plus 18. That will be half into, this is 32, 14 and 18, 32, 3 here. So this is, we can cut by 2, will get here 16. This is 16 by 3 square unit. So dear students, this area is the required area for question 3. Dear students, I hope you have understood how to solve this type of question. Keep practicing at home. Do your homework properly. Submit your homework timely. See you again in the next class. Till then, Assalamu alaikum.